This video is a part of the 3D CAD Tools Workshop of TASTE brought to you by SAINTGITS IEDC. This is a tutorial for 3D CAD using Onshape. In this particular video, we will show you how to design the top rod of a shock absorber and its subassembly using Onshape. In the last tutorial, we designed the part nut in the nut workspace on Onshape. We said that there was one step remaining, which was to cut a thread in this nut, and we would use this part, the top rod, to do so. So we need to add a part in Onshape. So how would you create a new part in Onshape? If you just go back to this Onshape documents, you will see that this document named nut is actually not a part, but a workspace. So we could just rename it to nut and top rod, and we'll have to create a new part in this workspace itself. So how you would do this is we'll hide this part and start sketching. Okay, so how you would do this in SolidWorks is that you will go create a new part, then save it to a folder, and then you will insert it into the part. That's because SolidWorks is an assembly driven program. That is, it focuses on creating parts so that we can form an assembly, while in CAD softwares like Onshape and Fusion 360, we just intuitively create parts on the way as we create an assembly. That is, we are more interested in the final assembly in Fusion 360 and Onshape, while we are interested in the individual parts in SolidWorks. It is also possible to do both approaches in each of the softwares, but we will continue with this method. Okay, so now let's begin with the top plane. Use normal to, and for the part that we have to design now, from the top plane we see it as a circle. So we'll start with a circle, click on sketch, create a circle. Okay, give the dimension as 24 mm and we'll extrude it. We'll give the extrusion height 108.93 mm and click OK. Okay, so now we need this fillet on this top rod. So we'll click on this edge here, click on fillet, give a fillet radius of 6 mm and click OK. So the fillet has been added. We need to cut off these rectangular portions from here, so we'll make the front plane visible and sketch on the front plane. Okay, so we need to start from this end, but we just noticed that this end is actually this circle, which is not part of this sketch. So to use that circle or that circular end, we use this function called use. Actually, what this does is that it finds the intersection and transforms it into a line. So we have a new point here from which we can start sketching. Okay, so let's view this normal to and create a rectangle. Okay, so we'll give the dimension as 20 mm. Let's give an axis here. So start from here about this midpoint. You see this midpoint is always highlighted by this square right here. Draw a vertical line down there. Okay, that's done. We'll set this to construction. Click escape, mirror entities, select the mirror line, select the entity to be mirrored, select it line by line. Okay, we just selected it, so it has been mirrored. Okay, click escape, give a dimension to these two lines. The distance between this should be set to 15 mm. Okay, so now the profile for cutting off is ready. So We'll click escape. We'll go to extrude and remove. Since we need to remove this from either side, we'll set this to symmetric. Okay, that's fine. Through all would be fine. Okay, so that's it. Okay, so click OK, so that the new surface has been created. So now we need to add this hole in here and also add this extrusion here. Let's create a hole by sketching on the right plane, just making this normal to us, and you could make this visible. Add a new sketch. Okay, first we need an axis right about here, but since we can't use this end line, we have to click on use to use this line. Okay, so that has been done. We'll add a new line from the midpoint here down here. Okay, click escape, set this to construction line. Okay, now that's done. We'll add a new circle right about here. Construction. Okay, so click on dimension, uses a dimension of 8 mm. Okay, set the distance from the top to be 10 mm. Okay, so now the circle has been fully defined. We'll extrude this. Okay, extrude remove. We'll give this through all symmetric. Okay, so we have a hole right there. Click OK. So the extrusion has been done. The next step is to add this projection here. So we'll do that by going to the right plane, clicking a new sketch. Okay, let's view this horizontal 2. Okay, click on circle, draw a new circle. That is okay. So we need to make this concentric to this circle. So to do that, we'll just click on concentric. Okay, just define the dimension as 18 mm. Okay, so now the circle has been fully defined. We need to extrude this, but we must remember that this hole must be kept. So we will do that by finding the intersection of this cylinder with this sketch plane. So we'll click on this and click intersection here. So a circle has been made there. Okay, so click escape. Now we'll go to extrude and set the extrusion to symmetric and the dimension to be 25 mm. Okay, so now the projection has been made. The next step is to add this thickness to this road there. So to do that, we'll go to the bottom side of this, view this normal to, sketch a circle there, a circle quite larger than the other. Set the dimension to 27 mm. Okay, we also need a hole that goes through this top road, so we'll sketch a circle as well. Let's set this dimension to 10 mm. Okay, so now we'll extrude this outer profile. Click on the profile, click on extrude and click on add. Set the depth to be 80.93. We will reverse this direction. Okay, click OK. So the thickness has been added. We'll remove this hole right there by making the sketch visible again. Extrude, click on remove. Okay, set the depth to be 75 mm. Okay, so the hole has been made. Okay, so now what we need to do is add this helical groove. To add this helical groove, we'll first go to the helix tool here, select, turn this to make this height and pitch, select the circular edge and give a height of 50 mm, give a pitch of 3 mm, and the helical path has been made. Okay, we'll just see that this helix starts about here, so we'll select this plane to draw our profile. So make this normal, and we'll see that this profile is more or less a triangle, so we'll draw a triangle here, drawing a triangle, set the dimension to be 2 mm, 2 mm, 2 mm, and the angle to be 60 mm, 60 degrees. Okay, so now that's done. We'll add a construction line about here from the midpoint to this vertex. Set this to construction. Okay, now we need to place this profile on the helical route. To do that, click this point and add a pierce to this. So it has been pierced. We will set this to be a horizontal line. We'll do that by adding a horizontal constraint. Click on horizontal and click sketch. Okay, so now it has been well defined. So the sketch has been made. We need to sweep this about this helical path. So we'll go to sweep and click on the faces and sketch regions to sweep. Select the sweep path, and yes, the helical groove has been made. Click OK. Okay, so we could just hide these curves there. Let's add this chamfer here to this bottom end. We'll click on chamfer and click on the bottom end with a chamfer of 4 mm. Click OK. So now the chamfer is added. Now we need to give a fillet to these helices. So we'll just go to fillet, give a fillet radius of 0.75 mm, and select the entities to be this helix and this helix. It would take some time to calculate because it's quite a long distance. Click OK. You can hide the sketch here. Okay, let's change this appearance. Okay, go to appearances, and instead of a part appearance, we will give a face appearance, and we'll multiple select these entities. The reason I did this multiple select is that we don't want this inside cylindrical hole to be colored. So I just selected all these entities and these end entities, and we'll also select this cylinder here to be colored. We'll set the color to black and we'll click OK. So now the part has been colored. We can hide these sketch planes here, and so now our part is complete. Now we have to add this thread or groove on the nut. To do that, we will make this nut visible. In SolidWorks, we would have to insert this part separately, but now since this is in the same workspace, we just have to translate this about this to upload here. So to do that, we'll just click on transform here, click the entities to transform or copy, click the nut. We will select translate by distance. Okay, we'll select the direction to be the cylinder so that it specifies the direction. We'll set the distance to be about 50 mm, so it reaches about here, and it's quite fine. We'll click OK. So now the nut has been moved about here. Now this is not complete. If we just hide the top rod, we can see that the thread has not been created yet. So to add this thread, we need to use a different function called Boolean. So from Boolean, we will click on subtract so that we can subtract material from this part by using this top rod as a tool. So you'll select this as the tool and we'll select the nut as a target. So on subtracting, we can see the preview already that the thread has been made. We'll click on OK, and so this part has been made. We don't want to lose the top rod, so we'll just edit the Boolean function, Boolean operation. We'll click on Keep Tools and click OK. Okay, so now both the parts are there. Now that this is not an assembly yet, so to make it an assembly, we'll go down to Assembly, click on Insert, and from the current document, click on the part 1 and part 2. We don't want to move it anyway, so we'll just click on the tick mark so that it is set on the origin. Okay, so now we need to establish a mate between these. The way we want this is that we need the nut to be moving along the axis of the top rod and about it. So the best mate for that would be the cylindrical mate. So before we do this, we have to make sure we have fixed the top rod. Okay, so now let's click on the cylindrical mate, set the mate connectors to something perfect. So we will select the cylindrical surface of the nut and this cylindrical surface of this top rod. Okay, so now the limits may be set, and setting these limits is totally a result of trial and error. Like it does not really mean anything, it just limits the movement of the nut with respect to the top rod. Let me just select it to 5 mm and 50. Let's see what happens. Okay, click on OK. I guess 50 is not enough. We'll set it to 60 and I guess it's quite enough. Let's adjust it later. Okay, we'll click OK and let's just move it about here. Okay, it's quite too much, so we will edit this. Go to cylindrical, right click and click on edit. Edit this, set this to 52 maybe. Click OK and we'll just try to move it about here and it seems quite fine. We'll add a 0.5 to it. We'll edit this, add a 0.5 there, click OK and yeah, it seems fine. This would be the tolerance. It doesn't really matter. So the cylindrical mate has been set. We see that the nut can be moved along the axis of the top rod and can be rotated about it. We need this to have a screw-like motion. So to do that, we'll add a screw relation. We add a screw relation, then click on the mate, that is this mate, the cylindrical mate, and then we'll set the distance per revolution to be 3, which is our pitch. Okay, so we'll click OK and try to rotate it. Okay, so I guess we have to change the direction. We have to reverse the direction so that it becomes clockwise becomes tightening and anti-clockwise is loosening. So we will edit this and click on reverse direction. So now when we rotate it clockwise, it tightens, and when we rotate it anti-clockwise, it loosens. We could just view it isometrically, rotate it clockwise to tighten it. Yes, it's always a good practice to rename your assemblies and parts. So we'll go to the assembly and right click on it, rename it to nut and top road assembly, render, go back to the part studio and rename the part 1 as nut and the part 2 as top road. Okay, so this way it's easy to find your files and use it in other documents. So that's it. Thank you for watching. Do try this tutorial out and keep learning 3D CAD.